Alright, ladies and gentlemen, welcome back for another lesson in Algebra 2. Today we're going to be talking about composition functions. So composition functions, the way I look at it, is a function inside of a function. Remember, a function is a fancy term for y equals. So it's function equals. So when we're talking about composition functions, we're doing a function inside of a function. So let me get my pen going. So here we have a function inside of a function. Okay, so let's take a look at these arrows. So we have function g. When we solve it, okay, we'll take that function and plug it into the final function, in which we get function inside of a function. So let's go ahead and erase these so we can do what it asks of us to do. Okay, it says we are to find g equals 9 right here. Okay, so we're going to put 9 here because g3 is right here and g3 equals 9, so 9 goes right here. Now it wants us to draw an arrow from 9 to 2 right here. So 2 will go right here. So when g3 equals 9, it will equal 2 for the function inside the function. So the function f, function g3, is 2. Write a rule for composition functions. So we have x minus 7, and we're going to write a rule for the composition function. So when you see this, that means we're doing a composition function. So it's an open circle, not a dot. Okay? So it is going to be f, g, x. Written, that is what it says. Okay. So here we have gx is x squared. So when we put it in our equation, we're going to put it in for here. So this is going to be x squared. Okay, and so this is the equation that we're using right here. So gx goes in for x. That's what it means by this, because this gx is actually x. So we're going to take that, plug it in for x. So we're going to have x squared minus 7 is our composition function. Okay. Now we're going to do it backwards. Okay. So let's do this backwards now. Let's erase all our stuff. Okay, so now it's wanting us to do it g f of x. Okay. And so it's written like, as I pointed out right here. Okay. So that means our this right here, our final answer, is going to be transferred down here. So we're going to have x minus 7 squared, because this is squared, and so we're going to have x squared minus 14x plus 49. Well, Miss Harris, how did you get that? Well, x minus 7, x minus 7. When we distribute, that's our x squared. And then when we distribute, we have negative 7x. Negative 7x, when we combine them together, gives us our negative 17. And then 7 times 7 gives us our 49. So I just distributed. Okay, evaluate immediately. X equals fx plus 7. Gx is x over 2. So what is the composition function of negative 2? Okay, so we're going to write it f gx negative 2. Remember, that's our composition function. Remember, this right here indicates it is a composition function. So what we're going to do, we're going to put our -2 in for x up in this equation up here. So it's going to give us a -1. So now we're going to find -1, because what we found here goes here. So we have the function of f, -1. Now we're going to put our -1 in our x from up the original equation, which is written right here. So -1 times 6 is -6, plus 7 will give us 1. So the composition function of -2 gives us 1. All right, find the composition function. Once again, same one from the previous page for the gx, but not for the fx, okay? So now composition of -2. So we're going to have f g -2, and we're going to do -2 over 2, which gives us -1. So we're going to do -1 right here because it is f -1. And so we're going to have -6 plus 7, okay, which gives us 1. That's from the previous page we finished, okay? So now we're going to have the -2. So we're going to put -2 here. And that'll give us -6 plus 1 is 1. Okay, so there's more than one way in which we could have done this. I do not like this second way. I prefer this first way. Find any domain restrictions. So domain restrictions when you cannot have a 0 in the denominator. All right, so the domain of G is all real numbers. How we know that is because there's no denominator. So the range of G is infinite. Okay. The domain of S is x cannot equal 0. Okay. Because the division by 0 is not allowed. But what makes it 0? Well, right here, x. So it can't equal 0. Now, if it's like x plus 2, then we couldn't say it couldn't be -2. But in this case, it's just plain x, so x cannot equal 0. Okay? Because we know we cannot divide by 0. It's not allowed. It becomes undefined. To find the domain, what we're going to do is a composition function where we're going to put x minus 4. So we're going to do x minus 4 right here. What we're going to do is we're going to do x minus 4 equals 0. Okay, or I should say cannot equal 0. And so when we add our 4 to move it to the other side to solve for x, as we are doing here, so that should be a positive, not a negative. So x cannot equal positive 4. So positive 4 is our answer right here. Okay, so there are different methods in which we are finding functions or individual functions, okay? So we have the square root of x minus 3, and then we have x plus 5, and it is a composition function. We're going to find the restrictions of this. Okay, so if you remember correctly, we can never have a negative number in our radical house or in a square root. Okay, there's restrictions on domain of f because you cannot have a negative, so I'll just put a negative symbol, number under a square root. So we're to find the domain. So x minus 3 must be greater than 0. Okay, and so when we figure this out, so we do x minus 3 is greater than 0. We're going to add our 3. So x has to be greater than 3. Okay. Use the domain of f to find the domain of G. Okay. So x plus 5 has to be greater than 0. So x has to be greater than negative 5. Sorry, I pushed the wrong arrow back. Find any domain restrictions on f, the composition of fg. Okay, so once again, we have this written out. Okay, here's the second way to do it. So instead of do it the way we did on the previous page, we would go ahead and we would put our x plus 5, okay, x plus 2. So we would say 2 has to be greater than 0, and therefore x has to be greater than negative 2. All right. So thank you for watching. I hope you enjoyed this lesson. Please come back for another lesson in Algebra 2. Thank you.